Hi, I know some of you had a bit of trouble with the quiz, so I'm going to go over some of the harder questions in this video and the next ones, look at the merit and excellence. So one of the ones that was trouble with was this question number 5, Kiwis on the island. It says, how many months would the stoat and the Kiwi populations be the same? Well, here's the Kiwi population, there's the stoat. So I'm going to take this one here and make it the same as that. So my left-hand side is the Kiwi and the right is the stoat. Now what we need to do, because we've got t as an unknown, we need to use logs. Did you like that one? So we take the log of the left and we take the log of the right. Now remember, when we're multiplying with logs, when we multiply, we add the powers. So if I'm taking the log, I'm making this a power, and the log I'm making that, I have to add those powers. That gets me down to the next one, is log is plus, and plus here. And then it's a case of changing these to numbers on your calculator and bringing the power out the front. Powers are powers we multiply. Now I'm going to do change side, change sign. So I'm going to bring the log of 0.95 to the left. It's going to become negative. I'm going to take the 2 to the right, that's become negative as well. So the other two places stay the same, change side, change sign. Then I can factorize this one here with a factor of t. So I factorize t out of there, it gives me those two parts. I do the right hand side. And the last step is to take the 0.4771 and divide it by this thing on your calculator, and you should get 16.6 for about 17 months. And that would be when they are the same. If you put 17 months for here and here, the populations will be roughly about the same. Factorize the equation below, this one here, 5x squared minus 6x minus 8. Because there's a 5 here, I'm going to use the ACC method, which is assume, calculate, and cancel factors. So I'm going to draw it here, and we're going to do 5x there, and 5x, and I'm going to divide it by 5. Because we've got a 5 there, we've got to do it to both sides. Do your signs. The last number is negative, so we know it's a plus and a minus. Then we calculate the first times the last. So the first times the last in each bracket. So we're going to do 5 times 8, 40. So it's 1 times 40, 2 times 20, 3, 4 times 10, 5 times 8. And 1's plus 1's minus, we've got a difference of 6. So 10 minus 4 is 6, but I want negative 6, so it's going to be 4 minus 10. Now I can see that this here doesn't have a common factor of 5, but the right does. So I'm going to write that as 5x plus 4, and I'm going to take a common factor of 5, which will leave me x minus 2 over 5. And now we can see that the 5's will cancel out here and here, and that will give us our answer. And so we're done. The answer is 5x plus 4 and x minus 2. So we've factorized that, and it's all nicely done. The next question was this one here. Again, factorizing is your friend here. So because I've got common factor of 4 there, I factorize the 4 out of the top. I've got a difference of 2 squares, so that's x minus 3, x plus 3. Now I can still factorize the top here, so I'm going to go 4, and it's going to be x minus 3, x plus 3, and x minus 7. This still equals 5 over x minus 3 and x plus 3. Now you can see that we're going to be able to cancel out, whoops, close the bracket, the x plus 3 here with the x plus 3 here. That's handy. Multiply the x minus 3 to the other side, and so we get an equation of 4x minus 7 at the top equals 5, and we're taking this x minus 3, we're multiplying it to the other side. Now we're going to expand those out, which is 4x minus 28 equals 5x minus 15. We can move the 4x to the right, so that's 5x minus 4x. We can move the minus 15 to the left, which is 15 minus 28. and then you get x equals negative 13. Now note you can't have a factor of negative 3 because that would make it 0, nor can you have a factor of 3. So there's our only factor, x equals negative 3. Sometimes these have two equations where we've got an x squared, but this one only has one. Now this one here, we've got to find the value of c there that solves the equation. Again, factorize. Factorizing is very important. So factorize the top with x plus 5x minus 4. And I've got a common factor of 7 here, so I take that out. Now, if I have a look at the top, I notice something. I notice that here we've got an x plus 5, and here we've got an x plus 5. So if I make the tops the same, this is a nice little trick, I could just times that with x minus 4. I'm going to times the bottom with x minus 4. Then I've also got the 7 is the same on the bottom. So if I expand out this on the right and see if it can match the one on the left. So let's continue with this. So what I'm going to do is I'm just going to write this was x plus 5. This will all be the same on the left. Over 7, 2x squared minus 5x plus 4c. And the same on the right now is x plus 5 times x minus 4. So we've got 7 bracket. Now let's expand that. That's 2x squared. That's minus 8x and plus your 3x. And these two come to minus 5, which was that one there. And 3 times negative 4 is negative 12. And so I can see then that this one here, the 4c, is the same as negative 12. Because everything else in there is the same. These are equal, these sides. So we've got this line. The top is equal to the top. And the rest of the bottom, or the 7 is equal to there. We've got the 2x squared is the same as there. We've got the minus 5x is the same as that. And so all I need then is this 4c to equal negative 12. So I write that 4c equals negative 12. So c must equal negative 3 divided by 4. Now the next question, what does it tell you about the value of c? Tell us about this. Well, if this can be factorized into two pairs of brackets, then it's factorized, there must be two real roots. So that's that part done, and we'll have a look at the other merit questions next time.